it's Paul. In this clip, I want to look at the various types of inflammation that we see in histologic sections and how we go about recognizing those. So we'll look at acute and chronic inflammation and granulomatous inflammation, and we'll also look at how the body attempts to repair damage by connective tissue repair. That's through the formation of granulation tissue that leads to fibrosis and scarring. Here's an example of acute inflammation in the lung. So you can see here the alveolar structure is still preserved. You can see those alveolar septa running through there, but this looks a lot more cellular than normal. Here's a bronchus, and you can see it's filled with pus, really, white blood cells. And on higher power, we can see that these are in fact neutrophils. Up here I can see some ciliated bronchial epithelial cells lining the bronchus or bronchiole, and then lots of neutrophils. I know they're neutrophils and not lymphocytes because I can see even at this power, I think, that they're not round single-lobed nuclei. And on high power, that's just confirmed. That's the ciliated bronchial epithelium again. You can see the little cilia lining into the lumen. This is a case of resolving inflammation of the lung. So this is further moved on from that previous one. And in this case, the leukocytes are starting to break down and they're forming that debris inside the alveolar spaces. And they're being mopped up by macrophages that will ingest that debris and the neutrophils that have died through a process of apoptosis. What happens sometimes is that the body attempts to wall off that inflammatory acute process and you end up with an abscess, and that's what's happening here in this specimen of gut. This is normal gut here with the columnar goblet cell. Notice all this muscle tissue, and then underlying that we've got this area of inflammation. Notice how it's got quite a bit of hemorrhage in here, so bleeding, and lots of neutrophils and lots of debris. So this is inside the abscess. If we look on higher power, you can see it's full of leukocytes, and also this one here is a multinucleate histiocyte, a giant cell we call those. They're often there probably as a response to foreign material that may have been leaked out. This is the collagen capsule around the outside of this as the body attempts to seal off that inflammatory process. You can see the pink fibrous tissue here. It's a lot less cellular. So let's look at chronic inflammation. The major difference here is in the type of leukocytes that's present. So instead of neutrophils, we have a predominance of mononuclear cells, particularly lymphocytes, usually a scattering of plasma cells as well. This is again a section of bowel. You can see once more the normal columnar epithelial cells, tall columnar cells with occasional goblet cells, that clearing. Then tracking around here, you notice there's so many cells in between all those glands. They are leukocytes. Chronic inflammation, looking at those under high power, you can see that they're mononuclear cells. And you can see quite nicely the goblet cells and the colonic epithelium there. Notice there's quite a lot of engorged blood vessels as well around the place. And so this is a chronic inflammatory tissue response. If we track down into the sort of depths of the ulcer there, you can see that it's the start of granulation tissue. And so notice these pink pale areas, they are collagenous areas, so it's collagen's been laid down by fibroblasts. There's a lot of engorged blood vessels here again. They're busy providing the oxygen and nutrients to this reparative process. Here's another example of granulation tissue. This is in a vaginal biopsy, and this is quite early on. So we've got chronic inflammation in the background here. We've got a lot of thin-walled blood vessels as well, lots and lots of those proliferating. lots of lymphocytes, and in some areas like here you can see they're starting to lay down some scar tissue. So that's very fibrotic there with fibroblasts and wavy collagen fibers. So the process of repair by connective tissue scarring occurs where you have quite extensive damage to an epithelium that's not possible to be remodeled. And so what your body does is to replace that with scar tissue. And the process follows these steps no matter where it occurs in the body. Usually there's initially chronic inflammation, so a big mononuclear, particularly lymphocyte infiltration. You then get a proliferation of blood vessels, angiogenesis, in order to provide nutrients and oxygen and allow cells to migrate into the area. Then you get a proliferation of fibroblasts. Those elongate cells, they lay down collagen fibers, and eventually all of those cells die or move out of the area, and you're left at the conclusion with just scar tissue, and then it's made up of fibrous, collagenous, hyaline appearing tissue that's pink and doesn't have many cells or blood vessels present in it. Here's an example in the lung. We can see there's quite a lot of inflammation in through here. There's a lot of pigmented macrophages. And then in this area here, we've got a lot of fibrosis happening. Lots and lots of thin-walled blood vessels. You can see them branching there. And as well as that, we have lots of elongate fibroblasts present. And they are busy putting down collagen. Just high power showing the elongate nuclei of the fibroblasts. These are bipolar cells which have that very spindly sort of cigar-shaped nucleus. And you can also see lots of vessels full of red blood cells around the place as we move around here too. So these guys will lay down the scar tissue and move out of the area. This is just showing an example of what happens when that is complete. This is a lung biopsy in a patient who's exposed to a lot of silica, and this is a big scar that's been left. So this is the end product of that process of granulation tissue, and you can see it's really just pink, wavy, hyaline tissue. Quickly look at granulomatous inflammation. And so this is specific inflammation that's seen in a few different settings. One is a reaction to a foreign body, like a splinter, or sometimes due to pathogens like TB, or in some cases as a result of autoimmune diseases. The classic thing we see is granulomas. These are composed of epithelioid, that means epithelial-like histiocytes. Chronic inflammatory cells are usually present, lymphocytes, not always, and sometimes you'll see giant cells, those multinucleate histiocytes, and sometimes you'll see central necrosis as well, for example in TB. Here's a classic H&E picture of a granuloma. You can see there's a lot of chronic inflammation around the outside, and then these histiocytes inside there. This is an FNA of that, just showing the whole cells, and you can see we have a mass of epithelioid histiocytes here. They're forming like a cohesive mass, a bit like epithelial cells, but they're not truly making glands or anything. And the characteristic thing of these is that they have elongate, sometimes footprint or thong sole-shaped nuclei. You can see a few of them in here nicely. They've got that appearance of like a footprint in the sand. So in summary, we've looked at different types of inflammation. Acute, which usually leads to chronic inflammation if it persists for a long period of time. Granulomatous inflammation, which is seen in a few specific settings. And then the body body's response to damage that results in granulation tissue leading to fibrosis and scarring.